Hello, everybody. My name is Zach, and I'm here to share introduction to gRPC and using it in Kubernetes. I'm a senior solutions architect here at Mirantis, and I come from the consulting space and also the developer space where my background is I helped out a lot of customers, big companies, with their strategic decisions around software engineering and how to align that with their organization, modernizing applications, and educating on the latest architectures. So, just some assumptions about the audience. This is for technical folks, engineers, technical leadership, and architects out there. So we assume that they know the basics about application architecture, just client server things, familiar with HTTP and REST, and we'll do a quick recap on that. They know what Kubernetes is at the high level, and you also know like you're either new to gRPC or want to learn more about it or how it works on Kubernetes. So today we're going to cover the first thing. We're going to cover what is gRPC, where it's best used, why people are moving to it, what's the experience you get, what are some of the main features, what are some drawbacks and pros to that. I'm also going to demo gRPC, the experience of gRPC, and using it on Kubernetes, and then we'll be talking a little bit about how to get started for those that are interested, how to get started on gRPC. So what is gRPC? So at a high level, gRPC is a service-to-service communication protocol. So what this would mean is a service-to-service is like, let's say you're Amazon and you have a product service and you need to talk to you have a cart service and you need the cart service needs to talk to the product service, and the user doesn't see that, but for those two services to be able to communicate with each other, you need a protocol to be able to do that. So back in the day, the very first service-to-service communication protocol was something called RPC, which is a remote procedure call. And what that would mean is if you have a client and you want to be able to interact with the server, either get some information or request something, what would happen is you would have something called a remote procedure call, which would be the equivalent of calling a function on the server over the network. So it's as if you're local and you're calling a function directly on the server. And what gRPC is, it's that, but it's designed for today's needs. So with the emergence of the web, the dominant way that this is done, and it's been probably done for the last 10 or 15 years, is doing this through HTTP and REST. And let's see, I think we have a slide on covering what that is. So the way that this is done is through REST right here. This is just a visual representation of what of REST over HTTP, and basically this is an API right here. It just tells you a little bit about a zip code, and what it does is you do a get on this address here, and then it gives you some information right here. And I just want to draw your attention to that. This is text right here, and it's in a format called JSON. Just keep that in mind as we talk forward and how gRPC can help in that. So this is REST right here. You just do a get and you just get back this information right here. So why are people using gRPC over REST, which is the current usage today? So one of the top reasons is performance. So the way gRPC works is, I'm going to jump back a slide a second, is this is directly equivalent of calling a function directly on the server. And the equivalent of REST today is, as you can see, there's text here. So the client and the server have to read and parse this JSON text, which takes a lot of processing power and things like that. So with gRPC, it actually does, with a client to server call, it actually does it over the wire and binary. And that makes such a difference. You can get 3 to 10 times, it's around 7 times faster, but you can get around 3 to 10 times faster than JSON and REST today, which is huge. That text parsing takes a lot of processing. The other reason is the developer experience. So the way with HTTP is you don't have an interface for the web. So what this would mean is when you're requesting something from the server, you basically need documentation to say, hey, what calls can I have you, or you have to guess. So, but what with gRPC, you have a typed interface for the web, meaning like you know exactly what functions are available, you know exactly the types of responses you're going to get, and you don't need to serialize or deserialize objects. So you normally have this in statically typed languages like Java and things like that. And having this over the web is a very big deal because you're able to accurately predict what the exact responses you're going to get, and the ability to be the other thing is you're able to do this over a variety of languages. The client can be in Python and the server can be in Java, and they're able to talk to each other in a language natively. So that's one of the other reasons. And the other reason over HTTP and REST is you get a lot of features out of the box. So the way REST works is you make a request response, and you can do things like asynchronous calls and many messages and things like that. But you have to work around it, and it's kind of hard to do that. gRPC has that out of the box. And gRPC also has many other bells and whistles that are available, such as what we like to say batteries included, but swappable, like authentication, tracing, load balancing, and a couple other things as well. So these are the top three reasons that we see developers gravitate towards gRPC as a practice, and why they're going to it over HTTP. Let's talk about next. We're going to talk about where we see it used and where it should be used. So gRPC, just a very typical. Let's pretend this is Amazon. You're on the Amazon website, and the website makes a request to the web servers. Where we see gRPC mostly used is in backend to backend communication. The reason why this is because it has to do with the library maturity. And right now, gRPC is, and we're going to demo what this looks like in a minute. Is we see this. This is used backend to backend because the front end it's not really matured yet. The libraries aren't mature. They're not developed yet. And there's not, and also the modern web browsers, they don't support HTTP 2.0, which gRPC uses natively. So this is typically where we see it used right now. This is going to change. It may change in the future, but as of now, everywhere we see it used is into backend to backend communication. So next, we are going to go into some of the drawbacks of gRPC. So as we heard before, there's all these pros and why people are using it, but some of the reasons, some of the drawbacks to it is, as I mentioned before, front-end maturity. We don't see a lot of like JavaScript and front-end applications using gRPC because they don't, modern web browsers don't support HTTP 2.0, and the library maturity is not there. The other thing that we're going to see next in the demo is when we show the application of experience of making gRPC is there's a lot of code generation involved. And this is typically a yellow flag among seasoned developers. Because you end up having to change the code, and why even generate it anyway. But as we can see later, it's a little powerful. But these would be the primary reasons why it would not be used, or where it would not be used as a communication protocol. Okay, so next we're going to go into a technical demo of gRPC, but let's talk about what we're actually going to demo. So we're going to demo two different things right here. Is we're going to do a tour of what a typical gRPC application looks like. And we're going to talk about like how to interface with it, like how we do requests and responses. So we're going to go over all of that. And then next, we're going to actually show, since Kubernetes is a very dominant platform, or emerging dominant platform today for running applications, both custom and off the shelf, we're going to show what the experience looks like for that. So I personally did some research, and I made a gRPC application on Kubernetes, get to know the pros and cons, what's working, what's not. So we're going to go over all of that. So let's start off with the application tour right here. I'm going to zoom into our application. So let me go to what we were talking about before with protocol buffers. So just to set some context for this application right here, I'd like to imagine that we are a server-side developer. And this right here is a mock application. It's just a hello world application. All it does is it just sends a string of text, and the response that you get is that text with a random number written in it, and it's written in Golang. So that's the context for our demo right here. And we're going to show what that looks like in gRPC. But the first thing I'd like to show right here is what we were talking about before was the typed interface for the web, which is the protocol buffer. And this is just a file, hello world.proto. But I'd like to show to bring your attention to this file right here is what you would use a server side, a service. You'd basically give this to all of your clients, and they would be able to see exactly what functions are available and what they can call on your service. So for example, what we're going to demo today here is something called a hello service. And what it does is it has a function. It says, hey, you can do something called get message, where the user in the request sends a hello request, which is basically text. And we're going to demo this. And the user can expect a response, which is that same text, and then also a random integer involved. So what we can imagine the experience of gRPC is as let's say you're a client, they would give you this file, and you'd be able to code gen an application and build it. So that is so in the protocol buffer here, you have the exact, as you can see, like in the hello request here, we have a string. And this right here, we have a string, and then you can also in the response, they have a string, and then you have integers. So this right here it's purposely made to be language and platform neutral. So these will automatically convert into, if you're using Python, it'll convert into Python types. If you're using Java, it'll convert into Java types. And that's both on the client and the server end. So next, I'd like to show just a little bit about what is the experience like in developing gRPC. So what's going to happen, or what I'm going to show here, is we have this protocol buffer here. And what the developers would do is you would use something called you would use code gen. So there's gRPC comes with a tool right here. And let me show what this is. It's called Proto-C. So basically what would happen is, let me just go into a different directory here. If we run this command right here, what it's going to do is this Proto-C is it's going to, I pointed it to this, to our protocol buffer right here. And what it's going to do is it's actually going to generate, Golang code. So right here, as we can see, it's going to generate an interface for me called hello service client and get message. So now what I'm able to do is with this generated code, I can actually call it in my main code right here, and I can reference it, and I can type in, say, hey, when we actually get this get message, I want you to do all this. So basically it gives me the stubs for everything. So the experience that you can expect with both a server and a client side is you write your protocol buffer, and then you just generate the code. And then all you do is just call that stub right here. So let me run this. Let me show what this looks like in an implementation. So let me run our application. So what we're going to do is this right here, what we're looking at is easy, and this is what I recommend to do. This is an open source tool. It looks like Postman. So this is a tool right here to interface with gRPC. And I wrote down what does the request look like? It's hello request text. And we were expecting this as a response. So I'm going to invoke it, and I'm going to send it a request. I'm going to send it, let's say test 8. And this right here is going to call my gRPC, and it's going to return something. So what all the mock application does is I'm sending it test 8. Your request was test 8, and a random integer is this. So this is just a mock application, what it does, and we're going to show this on Kubernetes. But when you're a developer and you're testing, I would recommend using one of these tools right here to be able to do this. It's similar to Postman. So next, what we're going to look at is what this looks like on Kubernetes. So I'm going to go to my code, and So we have this application running locally, and one of the challenges, we have Kubernetes out there, and it's a very big application platform, and we're going to look at like how this interfaces with gRPC. And there's two ways to do this. So I wrote right here, which is for those that aren't familiar, this is a Kubernetes manifest. So this defines what an application should look like running on Kubernetes. What is its infrastructure? What is the application? Those sort of things. So I'd like to draw everyone's attention. The main thing that you'd want to focus in on, or what's going to be different with gRPC, is something called this liveness probe right here. And what a liveness probe, and you have two different probes in Kubernetes. You have a liveness probe, and a liveness probe just checks, hey, is the container and the application running? That's what that does. And it also has some other parameters here, such as wait 10. You typically would want the application to boot up before you go out testing it. So we have it wait 10 seconds. And we also have another here, which is the period seconds, how long we want to check. The other type of probe, and we're going to go into this next, is a readiness probe. And a readiness probe it asks the question, is the application ready to serve traffic? And we'll go into that in a second. But let's run this. Let's show what this looks like running on Kubernetes. So I'm going to go to my terminal here, and I pre-wrote some commands. So the very first thing I'd like to do is, I had this running before, is I'm going to tell Kubernetes just to delete all the resources that I made before if they're not there. And then the next thing, what you do is you tell Kubernetes, I'm going to tell Kubernetes, for those that aren't familiar, this is going to read this this manifest file, and it's going to build all our resources out on Kubernetes. So I'm going to go ahead and I'm going to go tell it to do that. So it's going to go ahead and it's going to make all these resources for our application. It's going to make a service, which is basically like a proxy. It's going to make our application, and then it's going to make a namespace. So now that we have that out there, let's go see if it's up and running. So this is also how we check. We're going to check to see if the service is up and running. So as we can see, the service is up and running. And the next thing I'm going to do is I'm going to tell Kubernetes to, hey, expose this service so we could call it locally. So what it's going to do is it's going to open this. It's going to open this service up to me, and we're going to check out what this liveness probe is. But I just want to demo the application that we had before on Kubernetes. It's going to give me this new port here. So we're going to copy that port. Let's make a new test. Let's make it like test 8, test 9. And we're going to send this over. And as we can see, the application is functioning as expected. And I'd like to draw everyone's attention to, we're going to describe this deployment. So what you want to do is we want to see like, hey, is Kubernetes now has the functionality natively to check if the application is running. So let's go ahead and run that here. So what we're seeing here is the liveness probe. Let's see if we could find it here. Where is it? Right here. So the liveness probe that we had right here is, as we can see, it attempted a few times, and it was eventually successful, where it is constantly checking Kubernetes. You can have before they had this for HTTP, but now they have this for gRPC. So as we could see, the Kubernetes is successfully checking, hey, is the container running? The next piece that we have right here is the readiness probe, which I mentioned before, is to see if the application is actually serving traffic. So I actually did some research before I went out online to see how we can get the readiness probe going. And basically, you have to conform the application to meet this interface right here. Hey, like have something called health check request. And then it responds with, is it unknown? Is it serving, not serving? And I did some research out here on how to do this. And this did not work as expected, the health check interface. So I would recommend for now, if you're building a gRPC application, to not use the native, at least not now. It wasn't working exactly how it was expected, the readiness probe. But the liveness probe does work. The alternative I would recommend is making like a local script that the readiness probe can call, rather than just using the native readiness gRPC to see if it's ready to serve traffic. So that's one of my recommendations right there. Okay. So next, I'd like to talk about getting started with gRPC. So the first thing I recommend to do is I would go out there and I would read more on their documentation out there. Has great resources on introducing the high level concepts of gRPC, just the things that we discussed. I would recommend and going to take a read out there, and I would also read on some of the concepts. So these were just some of the basic concepts and what are some of the core concepts. But I'd recommend taking a read through these the very first thing. But the really big thing is the way that at least I got started really quickly was actually going out there and building like a Hello World application using one of your favorite languages out there. So these are the current languages that are supported out there on, and I'm sure that there's some even more out there on Kubernetes. So I wrote this in Golang. So what I would recommend you go out there and do is you go to the quick start for your preferred language. And I would run through the Hello World. They have another Hello World tutorial different from the one that we've developed here. And I would go in and I would just go in and build the very first thing you do when you build an application is define your protocol buffer or your interface. And then what you would do is you would, as we said before, is you would go out and you would generate the code for that. You build the stub code for that, and then you'd build your application around that stub code, basically. That's what it is at the high level. And then you can go ahead and you can update you can go ahead and update your the protocol buffer here to say, hey, I want to make a change. I want to add a field, and you can go ahead and you can regenerate that. And just to get used to the flow of gRPC. So that's how I would recommend getting started. So just to conclude with gRPC, just a recap. It's a service-to-service communication. The developer, they're drawn to it for its typed interface, for its multi-language support, its speed, and all the bells and whistles added to it. And it's very easy to use and get started. So I recommend go ahead and taking a look at it and giving it a test out to see if it fits your application needs. And I'd like to conclude with we do have another upcoming webinar on May 16th with exploring observability with OpenTelemetry on Kubernetes. And I'd like to thank everybody for their time. Thank you very much.